Hello, my name is Anais Kahve and I'm a toxicologist here at Broughton Nicotine Services. I am going to talk to you about computational prediction models and their use in the field of toxicology. What is toxicology? Toxicologists are interested in understanding the unwanted side effects that exposure to chemicals can have in humans and the environment. We conduct risk assessments to determine whether the inherent hazard of a chemical and the intended exposure to that chemical will cause harm to an organism. In toxicology, we are interested in how a chemical will interact with parts of the human body, from different organs to the immune system to our blood. How a chemical will cause an effect is down to various factors such as the dose of the chemical, its inherent chemical properties, like whether it is soluble in water and the size of the molecule, and whether it can react with substances in our bodies. This relationship is known as a structure-activity relationship. Why do we use computational models in toxicology? Structure-activity reactions can be studied in a laboratory where a chemical is tested under specific conditions. In some cases, however, these experiments can be costly. Computational models have been developed to fill this gap. These models have been developed over the past 25 years and contain vast amounts of data. Toxicologists can use these models to predict the toxicity of chemicals where there is limited experimental data and use them as part of the risk assessment process. These predictions are based on the chemical's inherent properties as well as experimental data from structurally similar chemicals. Furthermore, these models reduce the need to use animal models for safety assessments, and since there are a lot of chemicals to screen that could all be potentially dangerous, the use of these models saves time where laboratory testing would otherwise be used. How and why do we use these models at Broughton Nicotine Services? Here at Broughton Nicotine Services, we use these models to help our clients better understand the potential harm that e-liquid formulations might have on consumers and help them select safer products. We use two types of models, SAR, Structure-Activity Relationship Models, and QSAR, Quantitative Structure-Activity Relationship Models. The main difference between the two is that QSAR models use artificial intelligence to make their predictions, whereas SAR models do not. There are several commercially available tools that can be used to make predictions, such as LeadScope, Derek Nexus, ToxTree, and the OECD QSAR Toolbox. Without these models, we would have next to no information on some chemicals that consumers are exposed to. Therefore, these models are vital so that we can ensure we protect human health and advance a smoke-free future. Thank you for listening. Goodbye.